So hello everyone, welcome back to my channel. Nowadays you would see a trend where everyone is talking about AI and AI agents. But in the real world, a true autonomous agent should do more than just follow instructions or call tools. It should learn from its mistakes and improve over time. While everyone is talking about AI agents, we are going to build one that doesn't just react, it actually learns from its mistakes and adapts over time. So before we jump into the agent implementation, we need to understand how memory plays an important role in creation of a fully autonomous agent. It starts with the episodic memory, the ability to recall specific past interactions. This helps the agent replicate successful behaviors when it encounters similar instances. Then comes semantic memory, long-term facts and preferences. From tone and context details to recurring patterns, this gives the agent essential context to move ahead. And finally, we have procedural memory, allowing the assistant to define its behavior based on feedback. Over time, the agent adapts its logic and becomes more aligned with your workflow. With all these three memory types working together, we will build an assistant that gets smarter and more useful every time you use it. Now let's introduce our multi-agent, a memory-enhanced email assistant where we are going to use tools like Langgraph and LangChain to create the agent. Okay, so this is how the overall system design is going to look like. So as I said that it is a multi-agent system, we are going to use three agents. The ones that are shown in the blue color represents the agent modules. So the first one is triage module. The second one is the response agent and the third one is the prompt optimizer. Don't worry, I'll explain these in detail in the coming sections. So when an email is received, the triage module will be triggered. This triage module is responsible for classifying the email into different categories. So we have three categories here: ignore, notify and respond category. Now if the email is classified under ignore or notify category, the control will go to the end. On the other hand, if the email is classified as respond, then the response agent will get triggered to compose a response and control will go to the end after that. Now you will also notice the ping boxes here. So these are memory blocks. I'll explain the functionality of each of them as we proceed. Oh, and we also have one more important block, which is prompt optimizer, which will continuously improve our prompts based on the user feedback. So let's get everything set up. First, install the essentials. Python.env for managing environment variables securely. Langgraph to build structured workflows for your agent, and LangMem to give your agent memory so it can remember past interactions. Now let's import what we need. Start with OS and load.env for environment management and use typing tools like typedict for structured data. From Langgraph, we get state graph to design our agent's workflow and init chat model to bring in the language model. Prompt template for formatting prompts and human message to handle user input. For memory, we use in-memory store and tools from LangMem to manage and search through memory. With all of these, your agent is ready to be built, structured, smart, and memory aware. Now let's load our environment variable. Use load.env to load the config.env file. This securely loads your OpenAPI key from the config.env file. And as you can see that we have already configured the key in this file. Next, initialize the language model with init chat model. We will use OpenAI's GPT 4.1 nano model to power our agent. And finally, set up the memory store. For simplicity, we will use an in-memory store with an embedding model from OpenAI for indexing. So next we will define our agent's brain, the state. We will use typedict to structure the state, starting with email input to store the incoming email as a dictionary, and then messages, a list that tracks the conversation history, and add messages to append new interactions. Lastly, we have the triage results, which will store the outcome of the triage decision, whether to ignore, notify, or respond. Next, we define the router class. It's a base model with two fields, reasoning and classification. So reasoning is a string that explains step-by-step reasoning behind the classification. And the classification field, it determines how to handle the email. It can be ignore, respond, or notify. And finally, we use LLM dot with structured output in bracket router, which configures the LLM to output the classification with this structured format, allowing the agent to make more informed triage decisions. So now let's first define a simple function for triaging emails. The simple triage email function takes in the agent state, extracting the incoming email from the state. We then create a prompt template. It formats the email's detail like the author, recipient, subject, and the body into a prompt for the model. Next, we send this prompt to the large language model with LLM router.invoke, which returns the classification, ignore, notify, or respond. Finally, the function returns the classification result, storing it in the state as triage results. So now, before we dive into the enhanced triage process, let's consider the limitation of zero-shot prompting. With zero-shot prompting, the model has to classify the email without prior context or examples, which can lead to less accurate or inconsistent results. Without relevant past examples, the model might struggle to make informed decisions, especially when dealing with complex or ambiguous emails. That's why we enhance the triage process with episodic memory, so the model can learn from previous interactions and make better decisions. Now let's look at the enhanced triage process with episodic memory. First, we define a helper function, format few short examples. This formats the previous examples from memory into a readable format for the LLM. We will include the email's author, subject, body, and the classification in the few short examples. Now in the triage email function, we retrieve the incoming email and the user's configuration. We then define a namespace for episodic memory, which allows us to search past examples related to the email. And after retrieving and formatting the relevant examples, we create a prompt that includes the email details and few short examples. Then we send this prompt to the LLM with LLM router.invoke function, and it returns the classification, ignore, notify, or respond. So now if we go back to our system design, you would notice that once an email is classified as respond, our multi-agent would need a response agent. Let's see how we can create one. So in this step, we are building a memory-aware assistant using create React agent. We begin by defining create agent prompt. This function combines the system prompt, which sets the agent behavior, with the ongoing conversation stored inside state messages. The system prompt is simple but powerful. You are a helpful assistant. Use the tools available, including memory tools, to assist the user. Next, we define a tool called write email. It simulates composing and sending an email and logs the action for clarity. Then we set up memory tools using Langmem, manage memory tool to store knowledge, and search memory tool to retrieve past insights. This is where the semantic memory comes in handy. We will put all the tools inside a list and store it inside a tools keyword. And once we have done that, we can create a response agent using create React agent API with the tools, prompt, store, and the LLM. So now it's time to connect the pieces and build our workflow using state graph. We start by initializing the graph with the agent state structure. Then we add our first node, the triage step, and we make sure to pass the memory store into the function. Next, we add the response agent as another node inside the graph. To determine what happens after triage, we define a simple router function. If the email needs a response, we move to the response agent, otherwise we end the workflow. With the edges defined from start to triage and then conditionally to either response agent or end, we are ready to compile the graph. And the result is smart modular agent pipeline that reasons, retrieve memory and responds automatically. And this is how our agent is going to look like. But as I promised, we are not just going to make it a dumb system. We are going to make it autonomous, where the system can receive the feedback from the user and then optimizes the prompt accordingly. And that's where procedural memory comes in handy. Procedural memory allows the agent to learn and improve its instructions. This requires a separate agent, an optimizer, to update the prompts based on the feedback. Okay, so before our agent can optimize, it needs a starting point. We define two key prompts, one for triage and another one for the response. We store both these prompts in procedural memory using Langmem, using a namespace tied to the user. This setup not only powers the current workflow, it also lays foundation for autonomous optimization. So now comes the part that makes our agent truly intelligent. Prompt optimization based on the feedback. When a user provides feedback, the agent doesn't just log it, it learns from it. So first we retrieve the current triage and response prompts from the memory. We have then crafted a realistic sample email, a genuine question about API documentation. This becomes the context for learning. Then we build a mock conversation trajectory. It mirrors what the assistant might experience, the prompt, the user's email, and the assistant initial reply. With this setup, we don't just guess what the user meant, we simulate it. Next, we pass in the existing prompts, that is triage and response, along with its trajectory wrapped into the user's feedback. And the optimizer takes over from here. Its job is to analyze how well the current prompt handled the situation, then generate sharper, more aligned alternatives. And finally, we extract those improved prompts ready to be stored and deployed. And if the optimizer fails, no problem. We fall back to a manual improvement strategy based on heuristics. And once the prompts are optimized, the updated prompts are stored back in memory, ready to guide agents' future decisions. This closes the overall loop. The user interacts, the agent responds, and with each cycle, it gets better and better. So now we just have to rewrite our triage email and create agent prompt function in such a way that it retrieves the prompts from the procedural memory rather than using the static one. So as you can see here, we are retrieving the prompts for triage prompt from the memory. And also, if you see here, we are retrieving the response prompt from the memory. So both these functions, when created before, were without procedural memory, but now they are integrated with procedural memory. So whatever changes happens inside the triage prompt and the response prompt, these two functions will keep on using the latest prompts from the storage. So now let's run it and store some memories. And this time we are not just reacting. This email from Alice, it's a test, but the system treats it like a real deal. First, we pass in the email and an empty conversation history. Then our agent begins to stream results. It decides how to triage the email, chooses whether to respond or not, and if needed, it drafts the response using tools and memory. And each decision, it's stored, it learns, and it adapts. This isn't just a one-off run, there is memory in motion. Now let's also put some few short examples for the memory. So we're adding one more example here along with its label. and we are going to store it under our episodic memory under test user. Now with some modifications to our create email agent function, we will be able to create an agent which adapts with its procedural memory. So we are going to define a workflow again. We are going to add a triage node, but this time if you see, we are not using the simple triage email function. We are using triage email with procedural memory. And the next thing is to create a response agent. And again, if you see here, we are using the create agent prompt with procedural memory here rather than using the create agent prompt function. Now, once we have done that, we can add that node inside the workflow, and we can add edges from start to the triage node, and then conditional edges from triage node to the response agent and the end nodes. Now let's compile the graph, and then we can just run it. So now let's run our overall agent. So first we are going to process an original email to capture before behavior. After that, we are going to add a specific example to the episodic memory along with its feedback. Then we are going to call the optimize prompt, which is going to optimize our triage and response prompt. And then we are going to create our agent again, which is going to use the new prompts. And then we'll rerun our agent using the same email. So let's run it. And as you can see, before optimization, the triage function was saying that it has to respond to the email. And the response was, how can I assist you today? And as you can see that the information has been added to the episodic memory. Now the optimization is going on. And now if we can see that the response which has come from the agent is slightly different from the one which we have got in the first attempt. So now it is, how can I assist you today? If you have any questions about the API documentation or other topics, feel free to let me know. So this is much more specific about the email which has been passed to the agent. And as you can see that the feedback which has been provided to the agent is also related to the API documentation. And now using the optimized prompt agent, the feedback and the procedural memory, the two prompts, that is triage and the response prompt, has been updated in such a way that it gives a better response. So this is a way you can actually create a learning agent which can learn over a period of time based on the feedback provided by the users. So now just a recap of what we have done. So we have created a system that can take an email as an input, and it can triage it to ignore, notify or respond kind of a email. Now if the email is being tagged as respond, the response agent is going to come into the picture and is going to draft an email, and then the control will go to the end. But that's not it. In between, we are using different memory systems, that is episodic memory, which is storing the past examples for few short learning. Semantic memory, which is storing the facts and context via memory tools, and procedural memory, which is storing and improving the system prompts based on the user feedback.
This video is produced in collaboration with Near Diamond. I am creating these videos with his expressed permission to use his GitHub repository for code examples. All code and content referenced are credited to Near Diamond, and I am grateful for his support and collaboration in bringing this educational content to you. Please check out his GitHub for more of his work and insights.